approximation under the curve, like the RAM, LRAM, RRAM, except I use the trapezoid. I think I've talked about that. Okay, so you can see that if it were a rectangle, either an LRAM or an RRAM, it's not as accurate as a trapezoid is. Okay, so you're making trapezoids under each curve. By the way, based on what we have here, these would be underestimates of the actual area under the curve. In what circumstances is it always going to be an underestimate?
It is concave down.
Very good. So if it's concave down, a trapezoidal approximation will always be an underestimate. If it's concave up, a trapezoid is going to go outside of the curve, so it'll be an overestimate.
Well, if it's below, if it's above the x-axis.
No, it's always going to be. If it's below the x-axis, then it's just going to be.
We're not going to get into that.
Absolute value.
You're both correct. All right, trapezoidal, it's a formula. You were actually.
Yeah, you were.
Okay, so there's as many twos as you need, and then the last one will be by itself. This is in your book. Okay, so H represents the width of the partition or the interval. So H is always B minus A all over N. 8, and that's not new. We've used H before. It's always the Y value plus 2 times 2, all those Y values, and then the last one's out. So the first and the last ones are just regular Y values. Everything in the middle is times 2. Yes?
Okay, so I'm not trying to be really technical, but like, it kind of looks like a rectangle. Like, is there ever going to be rectangles with the trapezoidal rule? Like, say if you're like directly in the middle, kind of like that.
It's possible.
Like, would you just do length times width if you had that? Or would it always just be trapezoids?
It'll always be trapezoid,
Okay.
unless I don't understand.
She's saying, could you be equally?
Oh, if it's straight across?
Yeah.
Yeah, that's
Then
right.
you'd be right. Yeah.
Then,
Then you would probably just do like if you had to find the area under the curve of this,
yeah.
I would not use the trapezoidal rule. I would use base times x. Yep.
No, that's
At least in that interval.
I mean, she means like at the bottom of the parabola, if it's in the middle, so
Yeah.
that where the 2 points
Actually,
are
never
same
mind.
point.
I understand
Okay.
what you're saying.
Alright, so this is the formula. You're going to have to memorize it. It's close to what Simpson's rule is. I'll give you that in a little bit. So let's do an example. Let's say I've got...
You have to memorize it, or can you store it on our calculator program?
You have to memorize it.
It's on our calculator, isn't it? Yeah.
No, it isn't. It's not on there. It'll apply the trapezoidal rule. Your calc program will only work if you have an equation. So if I give you a bunch of raw data, your calc program, like over there, your program doesn't help.
That'd be mean.
It's not that hard to memorize. Okay, so let's say I have this, and I want to find the area under the curve. Let's say from 0 to, I'm going to go with 4, sure. And let's make 8. That's how many partitions we're going to do. So graphically, what we have is parabola at x-intercepts of 0 and 4. I don't know if I'm loving it or not. Weird. Alright, so if I want to find, using trapezoidal rule, what's my h going to be, by the way?
That'd be 1/2.
It would be 1/2. Very good. B minus a, my distance is 4. And my n is 8. So h, in this case, is 1/2. So applying this formula, I have 1/2 over 2. I would think of it as 1/2 times 1/2. Divided by 2 is same as multiplying by 1/2, so we get 1/4 out front. Okay, so the next thing we have to do is find my y. This is probably going to, this would be 0. It's the same thing, depends.
Shouldn't it be A?
Y, yeah, and also y of a would be fine. Okay, so my first y value, in this case it is y of 0, plus 2 times my next one would be y of 1/2, right? Because we're going up by 1/2 every time. Plus 2 times y of 1, plus 2 times y of 3/2, all the way. My second to last one would be 3.5, which is 7/2. And then y of 4. Okay? I mean, I'm not going to find out the individual y values, but that's how you would do it. By hand, write it all up. Hey, and we're going to do, let's do this problem right over here. Using the trapezoidal rule. Did you keep up, Jenny? Yeah. Try it. Try to do that problem using the trapezoidal rule. You can pause it, I suppose. You don't have to stare at the board while I work. You didn't know this is what you're getting yourself into.
Yeah, it's good to teach, not to